Good afternoon, everyone. My name is Terry Rooch, and this is Serious Automotive Training. Welcome back to another great module of mine dealing with General Motors powertrain performance. We're up to number 6 in a series of modules dealing with powertrain performance for General Motors. Today's topic is the PCV valve. The PCV valve is an acronym for the positive crankcase ventilation. So what that means to you, the fact term that I want you to remember, it's an engineered vacuum leak. So the PCV comes a long way in history for us, all the way back to the 40s. I've seen, as a matter of fact, there's a 48 Nash about 100 yards from me that has a road draft tube on the bottom of it. Actually lubricates the PTO chain. So prior to 1963, just a little history on the valve itself. They had a system which just designated itself as a road draft tube. The lower pressure underneath the car was able to pull just from the draft from underneath the vehicle or the truck, was able to pull that fumes from the crankcase outside the truck and onto the ground. Now, why do you want to do that? Well, I'm going to tell you why. Two big benefits of this valve right here, this tiny little PCV valve, okay? Two benefits of this. One, it reduces sludge inside the engine. How does it do that? Because it prevents the moisture from staying inside the pan, the oil pan, the crankcase itself, so it eliminates sludge or lowers the sludge, okay? Number two, it also prevents oil leaks. You walk around any junkyard, you open the hood, and you see engines full of oil leaks, filled with oil leaks. Well, guess what? This is the pressure valve. When this thing gets clogged, the pressure has nowhere to go. It starts pushing seals out. Rear main seals, intake seals, camshaft seals, you name it, you're gonna get some oil leaks from the pressure. So, two big benefits of the valve. The history on it, like I said, prior to 1963, it was a road draft tube. 63, it started showing up somewhere around California, and that's when we first started seeing these on new cars. So in Pennsylvania, in my county, if you have a 1963 car and it had this valve put on it, it still needs to be put on it to pass your state safety inspection. How about that? It's an emission component that needs to be checked. So if it came with it in 63, it needs it. So let's go down the list here. What's important to remember is you're driving a new car today. What's the first thing it does at a red light? The engine shuts off. Why? Because if you look at our chart here, the blow-by pressure inside the crankcase itself is greatest at idle. Okay? Think about it. Higher RPM, that's when those rings are sealing that piston nice and tight. You got a lot of lubrication up there, and bam, we got a great seal. So the higher the RPM, the lower the blow-by pressure. Misconception to a lot of people. So remember that for your ASE test. So lower RPM, idle speed, that's when blow-by is greatest. That's why these cars shut off today. You get to a red light, bam, shuts right off. It's an emission standard. So, what's the emission standard? Well, 20% of emissions. If you take the vehicle's 100%, 80% comes from 60%. 60% comes from the tailpipe, 20% comes from the fuel vapors of the tank, and the last 20% comes from the crankcase. These blow-by emissions are what we're tracking here with this PCV valve. Please don't confuse it with PVC, okay? Now, some ways to check this. Obviously, when it's out of the car, make sure the hose is fine. Sure, shake it. If it's clogged, it's clogged. But you could shake it. They're pretty reasonable. I just priced one for $7. Okay, so don't be afraid to change it. And always make sure you put the right one in, because you could have problems if you put the wrong one in. So let's take a look at this. If you remove it and you have an older machine with let's say you have a 4-gas analyzer, something that some places are still using. Of the 8 states that still do emissions testing, you could still be using a 4-gas analyzer. Well, here, we could be checking the carbon monoxide content of that exhaust tailpipe. So, pop it out of the valve cover, plug it, and you should get an increase in your CO, okay? You should get an increase in CO. Why? Because you just starved the engine from oxygen. So by capping it off, the word that I like to use, the engineered vacuum leak, these are an engineered vacuum leak. That's a fact term I want you to remember. By capping this off, you're actually lowering the oxygen content going into that engine, so the CO theoretically will increase. Now, this is coming out of the engine. This is all pre-catalytic converter, okay? Pre-cat. Now, another great way to test this thing is when it's out. Obviously, pop it out. Put your thumb over it. If you have a vehicle that does not have a throttle actuator, so it's a cable. When this is plugged, bam, here's the magic number. Your CO obviously will go up about 1%. Like we said, it will increase, but 50 to 80% RPM drop. So you just removed that engineered vacuum leak. So when you plug this with your thumb, if you have a scan tool that's reading RPM prior to throttle actuators, you should have a 50 to 80 RPM drop. So remember those for your ASE test. You probably may see them. Remember, this is all pre-catalytic converter. So before the converter is what we're sampling, okay? Now, so we'll look at the valve here. Basic valve, it has two modes since there's a spring inside. It has a mode for idle and it has a mode for under load. So let's swing over to our CBT course here for Powertrain Performance, and we'll take a look at where this is mounted. It's inside the tube coming out of the valve cover. It's going right to intake manifold vacuum. So we take a look at our drawing. The filtered air coming from the filter has a bleed off hose, goes into one side, one valve cover. That air comes through the valve cover. It comes down into the crankcase. It's passing the rocker arm galley here down around the camshaft. So this is all crankcase pressure area. This is where the valve cover leaks. This is where the oil pan leaks. The rear main seal, all from this pressure if this is clogged, dirty, kinked. So the PCV valve is on the other side. It's installed into usually it's in the valve cover, but the hose itself is what goes underneath the throttle plate. So the hose is connected to intake manifold vacuum. So filtered air comes through, down into the crankcase, pulls up through the other side, and comes back in underneath the throttle plate. And all those hydrocarbons that are passed by the engine at that idle speed or even at off idle, they're recirculated back through the engine and they're burnt again. So it lowers hydrocarbon emissions. Again, a great way to check it. With a 4-gas, pull off that CO, pull out that 4-gas analyzer, cap it. You should see the carbon monoxide level go up about 1%. That'll tell you if it's functioning. So let's take a look at our next screen here. So again, this is a replay of the entire system. So as the filtered air comes in, it's moving down through the plenum. Okay, the back side, it's coming down here to the galley, to the crankcase, pulls back up inside. PCV valve is allowing it to blow through back in the plenum, and it's reburnt. So it's just a cycle. It's a cycle of operation for the positive crankcase ventilation valve. So it's positive pressure comes from there. So let's take another look at the way this valve actually works here. I'll get around this side here so you can see. So take a look at our valve. So this would be our valve. Inside we have the valve itself, which is moving, and a spring. So the way it works is when you're at idle, you have high vacuum. The valve is pulled shut. While it's pulled shut, it still has that engineered vacuum leak. So it's still allowed to leak past the valve. Doesn't completely clog it. Okay? So it's at a low leak level. That's when we have the highest blow-by pressure. We turn around and now we get on this thing pretty hard. We're into it heavy. It's got a lot of load. We lose vacuum at the back side of the throttle. Now we're under load. Well, what happens when you go under load, that spring overtakes inside, and now the spring pushes the valve down. So when the valve is down, all the pressure that's coming past these rings is coming into the pan and goes right through. So it's I don't want to say it's a higher flow, but it's an unengineered vacuum leak. So think of it in two terms, idle and load. Okay, the spring will control the valve inside. This is where it would get contaminated with sludge if it gets clogged. Hey, you could have oil leaks. You could have buildup inside your motor for sludge. Okay, so there is a benefit to changing this. along with the emissions side of the house. Okay, so again, we talked about the flow here. Just coming in, filtered air, there's usually some type of screen on this side. They're the ones that get filled up with oil, so make sure you change those too. It's a breather screen. Change that when you change the valve too. We're coming down, filtered air, back up, catches on with the blow-by gas, shoots back up, and comes in through the valve, boom, right underneath the plenum. So make sure you check it. If you can't clean it, change it. It could cause the engine to stall if it's stuck open. It could also, like I said, if it's clogged, here's the downfall. You'll build up sludge and you'll get oil leaks. So this is just a short video today from GM Powertrain Performance. Next, we're going to follow up getting into the 4-gas theory and 5-gas theory before we get into the catalytic converter and the different inputs. So keep following me on my YouTube channel. Again, Serious Auto Training at yahoo.com. Follow me on LinkedIn at Terry Rooch. Or hey, just give me a shout on YouTube. Again, thanks and have a wonderful Powerball day. Thanks.